So in this video we are going to discuss the Cauchy's differential equation. So this we have going to first understand the introduction part, identification of the certain type of differential equation so that you can apply this type of formulas in that. Now second thing is that after applying we are going to solve one problem. So if you want directly to see the problem, kindly forward this one. So basically we are going through now the introduction part. So suppose a linear differential equation is in the form of what this thing you can see over here, x power n into d n y by dx power n. This is basically, you can see the n is there, okay, nth order. Now plus a1 into x power n minus 1, then d n minus 1 x n 1 minus so on, it is there. In the RHS part you can see r of x is there, that is nothing but a function of x, it is given. Now a1 a2 a3 in the given question you can see that is nothing but what, the constants. And on the RHS side we are having a function of what, x. Now this is nothing but a standard form, it is given for linear differential equation. Now what is our intention? Now this equation we can see x term is involved, right? X power n minus 1, x power n minus 2. That means it can be x cube, then x square, then x power 1, x, like that, so on, it can be there. Now this powers we are going to transfer into what, a constant coefficient, because we want to solve that question, right? So this equation whatever is there, that can be transformed into an equation with constant coefficients. Coefficients in the sense we are going to transfer this, the x power term, into a constant term. Constant we are going to involve there. So how to involve that? So we are going to remove that x term. So here with constant coefficient, by changing the independent variable what, x, to y by substitution method. So x we are assuming that we want to remove that x part. So x we are assuming what, e power z, where z is equal to e log x, also we can consider this too, anyways it is the same thing. If we take log on both sides it is the same thing. So z is equal to log x. If you differentiate z, so it will be dz by dx, which is equal to log x differentiation is with respect to x is 1 by x. Now if I want to find out dy by dx, it will be equal to, with respect to this, dy by dz into dz by dx. dz by dx is nothing but what, 1 by x. So 1 by x is substituted here into dy by dz, that is nothing but this part. So from this, if I shift this x towards the left hand side, it will become x into dy by dx, which is equal to dy by dz. Okay, and here I am going to assume that d by dz is equal to what, capital D. So d by dz I am assuming it as capital D, which is equal to dy. So I can replace, whenever I am getting a constant question where I am having this term x dy by dx, therefore I can replace it with what, dy. Okay, now if I differentiate this equation, so I'm going to differentiate that particular equation, then what will happen? These two are in what, uv form, multiplication, product form. So first into differentiation of second, differentiation of dy by dx is nothing but d square y by dx square. Then second term as it is, that is dy by dx as it is, into differentiation of x, first term, it is nothing but 1, which is equal to, on the RHS side also differentiation you have to do. So differentiating it will be d square y by dz square into, we are differentiating with respect to x, that's why we have to multiply dz by dx. Now again here you can observe that I am shifting this part towards the RHS side. So when I shift it will become minus dy by dx. Now if we see, this dy by dx can be replaced with what? See, if I send this x towards right side, it will become dy by dx is equal to x into dy by dz, right? So this thing can be substituted here. So in place of dy by dx, I can substitute 1 by x into dy by dz. So I am involving this dz here. So here also 1 by x is there, here also 1 by x is there. So you can take 1 by x outside. So what is remaining? Remaining is nothing but, see here, 1 by x from where we got, dz by dx is nothing but 1 by x. So we have got here. So 1 by x into, you take common, so we will be getting this part. Now if I shift this x towards the left hand side, you will be getting x square. So here, as we know that d, capital D is d by dz, we have assumed. So this part I can substitute as what? D square, and this part I can substitute as d, then y is remaining, so you substitute y, take y common, you will be getting this. Now next thing is nothing but the x cube we are considering. Suppose if you are getting x cube, then what you'll do? So always remember this formula is very important. Whenever you are getting the nth order derivative, so what you have to do, you have to just take it as d into d minus 1, it will remain as it is. But the thing is that d minus whatever is the order given, suppose if it is 3, you have to take it as 3 here, so 3 plus 1, so minus 3 plus 1 is minus 2, that's why it is minus 2. If it is x power 4 d4 and x4, then you have to take it as what? 4 plus 3 1, so minus 4 plus 1 is d minus 3. So like that, so on you have to consider. Okay, so that is the important thing you need to take care. So our main motive was what? See, while substituting, if I substitute all the formulas, all the things we got it in the equation, see all the values of this in terms of d, dy, d we got that values. If you substitute there, we are going to reduce the differential equation with what? A constant coefficient. So what was our intention? Our intention was to remove this x term, which is the coefficient of the differential coefficient of the dy by dx, d square y by dx square, like that coefficients was there that we tried to remove. So we are completely removing that and reducing it to a equation which having what? Constant coefficients. If you are getting this type of question, as you can see, we have not solved this type of question where we are having the coefficient of the coefficient as what? X square, x term was not there, right? We used to directly write as b square y, like that. So here the coefficient is there. So what you are going to assume is that, suppose x is equal to e power z, we are going to assume, or we can say if you take log, it will be z is equal to log x. Log on both sides, it will be z is equal to log x. Both are the same thing. Now we had to assume that dx into dy by dx, as we have seen in the upper, the previous case, that x into dy by dx is considered as dy, and x square into d square y by dx square is as considered as what? D into d minus 1 into y, so on, right? So wherever we are seeing this part and this part in the question, we have already discussed that you have to substitute as this part. Okay, so what we are going to do, we can see in the question this part is same as this part, so we are going to just substitute as d into d minus 1 into y. In place of this, minus is there, so put minus, then 2 is sitting, so 2 x dy by dx, it is nothing but dy minus 4y as it is equal to x power 4. Now the thing is that I have to change x power 4 also, because we have to remove everything, all the x terms we have to remove, replace it with what? The z term. So in place of x, I can substitute e power z. So e power z I will substitute, and one more power is there 4, right? On the LHS side, you can take y common. So it will be d into d minus 1 minus 2d minus 4 y common is equal to e power, multiply this thing, 4z. Okay. So here if you expand, it will be d square minus d minus 2d minus 4 whole into y is equal to e power 4z. Okay. Now here if you expand, it will be d square minus 3d minus 4 into y is equal to e power 4z. Right? We got this value. Now what we are going to do, we want to find the solution. Always remember, for finding solution, y is equal to yc plus yp we have to do. Always is the same thing for differential equation. So yc can be found out by, it is nothing but complementary function. We have to find out the yc, and then we have to go for a particular integral which is yp. Combine both, you will get the solution for this particular equation, differential equation. So finding yc is important. So what we have to do, we have to consider the auxiliary equation. So whatever is there inside the bracket, the function of d, after taking out y outside, so replace d with m. So it will be m square minus 3m minus 4 equated to 0 to form an auxiliary equation. Now from this, we can use this is a quadratic equation, we can use calculator if it is allowed. Second thing is that we can go by quadratic formula. Third thing is that factorization method. So we'll go by factorization method, which is quite easy if you are not using calculator, or quadratic formula is also fine. Anything is fine which is suitable for you. Now coefficient of m square is what? 1. So 1 into minus 4 is minus 4. So when you multiply two numbers, you should get minus 4. When you add, you should get the middle term minus 3. So multiplying that factors, I'll take 1 fours are 2 twos are. So which two numbers can be taken such that you will get 3 as the combination after adding? So 1 and 4 I can take because 2 and 2 I cannot get 3. So 1 and 4 I'll take. So I'll write the as splitting a middle term. M square as it is minus 4m plus 1m minus 4 is equal to 0. The thing here is that minus 4 plus 1 is the middle term minus 3. Minus 4 into 1 is minus 4. So it is getting satisfied. Now take common grouping. So m common from first group, it is m minus 4 inside. Here also m minus 4 should be inside equal to 0. So outside it will be plus 1. So m minus 4, m minus 4 equal. Both are common. So m minus 4 common. What is left out? M plus 1 equal to 0. So it is multiplication factor. So m minus 4 equal to 0 and m plus 1 is also equal to 0. So m value is equal to plus 4 and m value is equal to minus 1. So both the roots we got. Now what we can do, that yc we can find out. But the thing is that you need to understand the m values whatever you are getting, it is a real and distinct roots. Distinct in the sense different roots. So yc can be written as what? Suppose m is equal to first root alpha, second root beta. Anything is fine. Beta or alpha, anything. So yc can be written as c1 e power alpha x plus c2 e power beta x. Now alpha and beta you have to just replace with plus 4 and minus 1. So our final answer for yc is equal to c1 e power 4x plus c2 e power minus 1 is there, so minus 1x. 1 if you want you can write, otherwise minus x. So basically our question, if you see, this is the last part we wrote. From this we are going to find out the particular integral which is yp. How to find? The same thing we are going to apply. We have already studied the case for k into e power ax. The same thing we are going to apply here. Only thing is that the variable has changed to z. So be careful, we have to take it as z. So here, so it will be 1 divided by function of d. Whatever is there inside the bracket, just put it over here. So d square minus 3d minus 4. Then multiply RHS part e power ax. Here it is e power 4z. Okay. Now, as we have studied in the case of e power ax, that we are going to substitute the d value as what? A. Here a value is nothing but 4. E power ax, right? So a value is 4. So you have to substitute wherever d you see 4. So yp value will become 1 divided by, instead of d square it will be 4 square minus 3 into 4 minus 4 into e power 4z as it is, equal to 1 divided by 4 square is what? 16. So it will be 16 minus 12 minus 4 into e power 4z. Now you can observe that if you add this thing, 16 minus 16, it is 0. So this denominator has become 0. So if it is becoming 0, we have studied in that case, we have to differentiate. One extra step we have to do. Whenever you are getting the denominator as 0, in the case of what? K into e power ax. Okay, on the answer side where you are getting, this case I am talking about. So differentiate. So what you have to differentiate? We have to differentiate what? D part. D part we have to differentiate. The function of D we have to differentiate and multiply by what? There we took x. Here we have to take z as the variable. Okay, very important step. So I'm going to differentiate. What you have to differentiate? This function of D. So yp will become 1 divided by function of d. You can write f of t. So it will be d square differentiation 2d minus 3d differentiation minus 3 minus 4 is this constant which is 0 into e power 4z as it is. We are not differentiating e power 4x. Okay, we are differentiating only function of t. Now what about multiply with x z? So multiply numerator with what? Z. So numerator, remember this is numerator. So next part is that here also again we got d value. Again you have to do that step itself. That means d you have to substitute as a. A is not changing, it will remain as it is 4. Okay, so again we are going to substitute. So yp will become z divided by 2 into 4 minus 3 into e power 4z, which is equal to z divided by 8 minus 3. 8 minus 3 is what? 5. E power 4z. Okay. So yp value we got. Now we can write it as this thing as 1 by 5 z into e power 4z. This is the yp value. Now we have to combine both the values. So you will be getting what? Yc and yp. So y value is equal to yc plus yp. So yc value we know c1 e power 4z plus c2 e power minus z plus 1 by 5 yp value z e power 4z. But the thing is that I don't want in z value, right? We have just assumed it in the starting so that we can bring that constant value. We can remove that x and find out the answer using the similar way as we have done before. Now we have to again replace it with other values. That means we have studied that e power z is equal to x we took, or we can say that we took z is equal to log s. So wherever we are seeing y will become, see here carefully, this part c1 e power 4z is there. So right, so here e power z is there. So I can write it as x power 4, simple, plus c2 e power, again e power minus z is there. So I can write it as c2 x power minus 1 plus 1 by 5 z into e power 4z. E power 4z is what? E power 4z is x power 4, and z value can be written as what? Log x. So it will be log x into x power 4. Right? This is the answer. Now the final answer we'll write it as y is equal to c1 x power 4 plus c2, this you can bring it down, x plus 1 by 5, or you can write it as x power 4 by 5 log x. This is the final answer for the question.